Why is temperature explained by statistical mechanics in thermodynamics? Have you ever wondered how temperature connects to the tiny particles that make up everything around us? It turns out that temperature is much more than just a measure of heat. In the world of thermodynamics, statistical mechanics plays a key role in explaining temperature by linking the behavior of particles to the properties we can observe. Let's start with the basics. Every physical system, whether it is a gas, liquid, or solid, consists of countless particles that are constantly moving and interacting. Each unique arrangement and energy level of these particles is called a microstate. The overall observable condition, like temperature or pressure, is referred to as a macrostate. Many different microstates can correspond to the same macrostate. Statistical mechanics provides a framework that helps us understand how energy is distributed among these microstates. The concept of temperature emerges naturally as a parameter that governs this distribution. Essentially, temperature indicates how energy is spread out among the particles in a system. When we think about temperature, we often think of how hot or cold something is. However, in statistical mechanics, temperature is tied to the likelihood of a system being in a specific microstate with a certain energy level. This relationship is captured by the Boltzmann factor, which shows that temperature influences the probability of finding a system in various energy states. Now, let's consider what happens when two systems with different temperatures come into contact. Heat flows from the hotter system to the cooler one. This transfer continues until both systems reach thermal equilibrium, which is when they have the same temperature. This process increases the total number of accessible microstates, thereby increasing the total entropy of the system. According to the second law of thermodynamics, the total entropy of an isolated system never decreases, which means that systems naturally evolve towards states with higher entropy. Temperature also plays a vital role in phase transitions, such as melting or boiling. During these transitions, the arrangement and energy of particles change significantly. Statistical mechanics helps us understand how the probabilities of different microstates shift with temperature, explaining why ice melts into water or why water boils into steam. In essence, statistical mechanics provides a clear and precise explanation of temperature in thermodynamics. It connects the microscopic world of particles and their energy states to the macroscopic thermal properties we observe. By grounding temperature in fundamental physical principles, we can better understand heat flow, entropy, and phase changes, making these concepts more accessible to everyone.